Thank you all for joining me. It actually looks like there are a few folks. So give me just a minute to finish making sure that everything is working, and then I will go ahead and start. Just checking a couple things out here real quick. I'm actually not sure. I'm actually trying a different service to stream live, so I'm going to just see if it works. If not, I'll go back to the one that I've used in the past. All right, looks like it's working on Twitter. Looks like it is not working on YouTube, which is what's showing up on the website. So give me just a second just to check that out. Let me actually just edit the page real quick on the website to make sure it's showing up there. Whoops. Just FYI, while I'm getting everything set up, you are all able to chat with me. And if you chat, if you provide any feedback, any questions, anything like that on Twitter, on Twitch, or on YouTube, I should get them and I should be able to respond to you. Let me just put this in. All right, let me just make sure it's working on through the website. Yeah, I think it should be now. Yep, excellent. Great. Just one last thing I need to check. Just need to make sure that recording actually works for me. Because I'm both obviously streaming this as well as recording it. So let me just make sure. All right, cool. Looks like I just recorded something. Excellent. Whoops. Sorry, you don't need to hear me with a video of myself. Excellent. Okay, looks like it is all working. So this is going to be really pretty informal. If you have seen me talking about this, my plan, I'm recording lessons for a course that I'm releasing next month called Going Deeper with R. I've been working over the last few months to put it all together. And so I wanted to actually just live stream myself recording it because I think it's actually really helpful, for me at least, as an accountability measure to say this is what I'm doing and I'm going to do it. And I thought it might also be interesting for folks to see. So this is going to be pretty unpolished. I usually record multiple takes, kind of go back, and then after the fact I'll of course edit. So if you're looking for something polished, this is not it, but please do check out the course on the website. And you can see all sorts of information. Then, of course, when the lessons and everything are up, you'll be able to see that as well. Let me just check one last thing. Okay. All right. All right, awesome. Cool. So, yeah, I'm gonna just go ahead. And again, if you have any questions as I am doing this, I would love to have you put them in the chat. All right. Let's see. So the way I've structured this is I have another course called Fundamentals of R, and there's a kind of three sections of it. There's a data wrangling and analysis section, there's an R Markdown section, and there's a data visualization section. So I'm doing the same kind of module, same section, same topics essentially for the going deeper with R, but obviously we're going a little bit deeper. So I'm going to start out, actually in the fundamentals course, I think it goes it does go R Markdown, data wrangling and analysis, and then data visualization. For this course, I'm actually going to start with the data wrangling and analysis, and then move on to data visualization, and then finally do R Markdown. Okay. Hi, Dana. Thanks for watching. All right, cool. So, and I'm going to actually be kind of looking over here because I am going to kind of record each lesson in a separate video, which will make it easier for me as I am going back and record it, or and editing. All right, let me hit record. All right. Let's do it. Welcome to the Going Deeper with R course. If you watch my Fundamentals of R course, actually I don't like that. So, welcome to Going Deeper with R. If you took my Fundamentals of R course, you saw that I covered three main topic areas. There was R Markdown, data wrangling and analysis, and data visualization. For this course, I'm going to cover the same three topics, but in a slightly different order. I'm going to start with data wrangling and analysis. We'll then move on to data visualization, and finally, we'll get back to R Markdown. Okay. The first thing that we're going to discuss is importing data. In the Fundamentals of R course, you learned how to import CSVs. And I chose that format because it's a really common format, and I think it's one that a lot of folks work with. But of course, R can actually, well, let me start over. The first topic that we're going to talk about is importing data. In the Fundamentals of R course, you learned how to import CSV files, and I chose that format because I think it's really common. But R can actually import a number of other formats. In fact, basically any format that you can think of, there's a package that will enable you to import. So in terms of importing data, one of the first things to know, and one of the things that really kind of blew my mind when I started using R, is that you can actually download data directly using the download.file function. And it works like this. So there's download.file, and then you enter your URL, and then the dest file is wherever you want your file to go after you download it. And I'm going to demonstrate this in a second. Actually, hold on. I'm not sure that let me switch back real quick. Just thinking through this, because I have it set up so that people kind of watch for a bit, or see a video for a bit, and then there's like a my turn section where I demonstrate things, and then a your turn. Maybe it's okay. I was wondering if I should demonstrate downloading data right away, or if I should kind of talk through importing Excel files, other packages. That's fine. I think I'll actually just keep it the way it is. So I was happy with that slide. I think I'll actually move on to the next one and just start from here. Obviously, I'll edit this back together. One of the formats that R can import is Excel files, and that's of course really common for many folks coming to R. For me, for example, I actually came from Excel. So if you want to import these, I recommend the ReadExcel package, and that's the letters XL. It is part of the tidyverse, although it's not a core tidyverse package. So as you'll see in a minute when I demonstrate this, you're going to have to actually load this package separately. In other words, you can't just type library tidyverse and have the functionalities of the ReadExcel package. And I'll demonstrate this in just a second. The way the function is going to work that you're going to use, and the function is read_Excel, is that you are going to say the path. So same as you do for read CSV, read_CSV from the readR package. So for example, path equals directory name / file name.xlsx. And then you also have to specify the sheet. Now, if you're working with an Excel file that only has one sheet, you don't have to put this, but I recommend doing it just because, say you're working with an Excel file that only has one sheet now, but then you make some changes or someone else adds another sheet. You want to make sure that you've written code in a robust way so that in the future, any changes that take place don't impact your code. So I would always, for example, put the name of the sheet just to be safe. An example, hold on one second. Sure that I love how I set this up. So easy to have it make sense as you're putting the slides together, less easy to have it make sense as you're recording it. So the way I'm kind of thinking about it is having folks, I'm giving kind of the overall way that it works, then I'm doing kind of a toy example with a really small data set that I made up. It's not real, it's about German and French speakers. Again, not real, just something I made up. And then I am planning to actually demonstrate it using real data. Just thinking about this. Let me try it, and if I don't like it, I'll go back. So let's take an example. Let's say I have a file called German and French speakers.xlsx, and it lives in a folder in a directory called data/raw. I would open it using this, path equals, and you can see it there, and then sheet equals, say I just want to get the German speakers. So I'm going to use ReadExcel, and then I'm going to assign the results using the assignment operator right here to an object that I'm calling German speakers. And then I'm going to use the pipe, which you learned about in the fundamentals of our course. Essentially, just as a reminder, you are saying, do this, read the Excel file in, and then I'm going to use the clean names function from the janitor package, which again you learned about in the fundamentals of our course. And that will just give us really nice variable names to work with. So when I do this, you can see now I have, this is the result of it. I have states, so you can see I could see all the states. And then actually the variable names are actually cut off here. But it is number of German speakers in 2007. Oh man, this is not good that it's cut off. Hold on one second. Oh, that's better. That's weird. Why did it get cut off? Huh. It got cut off, but then when I hit next, let me refresh this. Okay, weird. That's better. Okay, I don't know why I did that. Let me start over on this one then. So just a kind of example here. Let's say we have a file that's German and French speakers.xlsx with dashes there. And it's in the data raw folder, data/raw. You can see I could list the path here, the path to the file. I could say I just want to get German speakers, so sheet equals German speakers. Just imagine I have an Excel file with multiple sheets, and I'll demonstrate this in a second. And I want to assign this to an object called German speakers. And then I'm going to use the clean names function. And when I run this, I get states here. I'm not loving this because it feels sort of abstract in that the people haven't actually seen the file. Just a second. I think maybe what I'm going to do I might actually flip back to R Studio, I should say, as I'm doing this to think about showing that Excel file. Let me just open it up. I think that's what I'm going to do. I think I'm going to actually show this file first, and then I'll show you how it works. Okay. All right, I'm going to start again. Actually, hold on 1 second. Whoops. Oh, okay, that's fine. I was confused because why I had German speakers, but then French speakers 2019. Okay, let me do this. Okay. Just wrap that. Actually, I'll just make these a little. Wider so students can see them. Okay, cool. All right. Let's say that I'm working with an Excel file that has the number of German and French speakers in 2017, 2018, 2019 in various states. This is completely fake data. I just made some random numbers up. So you can see the Excel file that I have. 2 sheets here. I'm going to start with just the German speakers sheet. Got state, the number of German speakers, 2017, 2018, 2019. All right, so let's say that this file lives in a directory in a folder called data raw. So I would do ReadExcel. Let's say if I just want to read in German speakers. So I do German speakers, and I just use the assignment operator, and then I do ReadExcel, and path equals data raw German and French speakers.xlsx. And then you can see here I'm doing sheet equals German speakers. Just as a reminder, that'll get this sheet, not the other sheet. And then I'm just using the clean names function because you can see over here, for example, our variable names have spaces between them. I'm going to use the clean names function, which will eliminate those spaces and just make them easier to work with in R. And that's from the janitor package. Okay, now that, 1 second, it gave me those funky names again. There we go. Okay. I'm just thinking about where to go back to. I think I'll just do this whole thing over again. All right, so you can see now I'm going to read. Actually, let me. That. You can see now I am reading in this Excel file. And I'm doing that by using the read_Excel function. And I'm listing the path. So the path is data/raw. Imagine this is in a data/raw folder, which it is in the project that I'm using to create this course. then the name of the file, and the sheet, which in this case is German speakers. And I'm going to assign this to an object called German_speakers. And the last thing I'm doing is I'm using the clean names function from the janitor package. You learned about that previously in the fundamentals of R course. If you haven't seen it before, it just cleans up our variable names and makes them easier to work with within R. Whoops, go that way. Cool. So you can see now I have state, number of German speakers 2017. You can see that the variable name has the underscores there, whereas, for example, here it just had spaces, which is more complicated to work with. Okay, so you can see now I have all of my data here. This should look really familiar to you. If I flip through, it's only showing me 5 rows here, but you can see I can flip through the whole thing, and I can go over to see my other variables. So I have imported an Excel file. There are a lot of other packages for importing data. If you have data in SAS format and SAS SPSS, there is a package called Haven, and you can check that out. It'll give you functions really similar to the ReadExcel function that will enable you to read in data from all of those in all of those formats and more. There's also a neat package called Rio, which makes it really simple to import and export data. You basically just have to give the location of the data file in the import function, and then it auto-detects the file type and automatically imports it for you. It's probably the simplest way to do it, but I actually prefer not teaching it because I want folks, at least initially, to be thinking about the data that they're using and making sure that they're using a package that is specifically designed for that. But it's a really nice option for you as well. All right. Let me just take a break for a second before I do this one. Let me just make sure. Yeah. All right, so for my turn, I am going to be working with data on 3rd grade math proficiency. And I will actually show you this in a second. I'm going to do the following. I'm going to make a new project. I'm going to create a new R script file where I'll do all of my data cleaning work. And then I'm going to download math proficiency scores from 2017 and 2018 and put them into a data raw folder. Then finally, I'm going to import these 2 spreadsheets because they come in Excel format into 2 data frames, one called math scores _17_18, and then math scores 18-19 as well. All right, let me flip over to R. You may be hearing my children outside. They're headed outside right now. I'm actually just going to pause for a second because I'm waiting for them to head out. I'm just going to look at this data real quick because I want to see something. All right. Oops. Let's see if I hit it out. Okay, so I am going to start by creating a new project. I'll just go to new project. Should be familiar to you. Did not work. What's going on here? Whoops, just a little slow. I'm going to edit this down in the actual course. So I'll put this in a new directory, a new project. And yeah, that's fine, that location. I'm going to call this Going Deeper DK because I have a Going Deeper course. You can actually see it's open here, which is my version of all the materials and everything that I've created. So I will create a project. Okay. The next thing I'm going to do is I'm going to create a new R script file. Excuse me one second. The next thing that I'm going to do is create a new R script file where I'll do all of my data cleaning work. One thing that I find when working with folks who are starting out with R is they don't know whether or not to use R or R Markdown. My typical advice is to do all of your data cleaning, all of any kind of prep work with your data in an R script file, and all of your reporting in an R Markdown file. I think that really separates out the functionality that the two were designed for. I think R script files, when all you want to do is just work with data, works really well. R Markdown is designed for reporting, communicating, sharing results. So I think using it for that purpose makes the most sense. Obviously, if you have a really simple project, it doesn't really matter. You can do it all in one R Markdown file. But I think when you get to any level of complexity, it really makes sense to split that out. So I'm going to make a new R script file. I'll do a new file R script. And let me just go ahead and save this. I'll just call this data cleaning. Okay, now I'm going to download math proficiency scores from 2017 and 2018 and put them in a data raw folder. All right, so first thing I'm going to do is I'm just going to make a folder called data raw. That format, that idea of using data raw, and then as you'll see shortly, we're going to make just a data folder. It's really common in packages that are made in R packages. Although we're not making an R package, I think it makes sense to use it here as just a way of kind of conceptualizing working with your data. Any raw data will live in that data raw folder, and then once we've cleaned up, once we've tidied our data, we'll put that just in the data folder, and that's what we'll import then when we're working in our Markdown. All right. So flip back here. All right, so just gonna take a pause so I can easily edit. Okay, so I'm going to first load the packages that I need. I am using the keyboard shortcut Command-Shift-R. I'm on a Mac, it's Control-Shift-R on Windows. I like to do this just to make section labels because then, as you'll see over here, I can easily navigate. So I'm going to load my packages. I'll go ahead and load the tidyverse, which we'll be using. I'm also going to load ReadExcel. And then I'm going to load the janitor package. So let me go ahead and I'll highlight all these, and then I'm just hitting Command-Enter. And you could also hit that Run button, but keyboard shortcuts are faster. So let me make a section for downloading my files. So now I have popped up, this is the link that was on my right here. This took me to this page, and I'm going to download data for math proficiency scores for 2017-2018 and 2018-2019. All right, so first I can do that. forgot which one I downloaded. There's so many different ones. Hold on, let me check this real quick. I'm going to open up, you can't actually see this, but I'm opening up a new session of RStudio. All right. Let me actually pop into my data raw folder and just see which one. First of all, while I'm doing this, I have to say that I'm impressed that there are folks actually still watching. Because as you can see, I framed it as this is how the sausage is made. It's very much that way. You can see it's not a linear process. All right, let me see. I think this was by groups. All right, let me pop back here. Wait, it's economically so it's not by race. I think it's this one. Yep. Okay, cool. Hold on, let me move that out of the way because I want it to appear just as it will for the students. Okay. Let me actually do this. All right, so the next thing that I'm going to do is I'm going to download this data. So let me actually click that link. Let me pull this over here so you can see this. This is the page on the State of Oregon Department of Education website. I'm going to scroll down to math. Now, when I was working before in other tools, the way I would do this was I would download a file. Go here, say, click it, download it, and then copy it into my project, say, or whatever tool I was using. If I was using SPSS, copy it, or to wherever I needed it to be, and then I would start working with it. Now that's sometimes fine. It's not necessarily the worst thing. Oh yeah, sorry, I shouldn't have stopped. Let me start this over. I feel like I'm all right, so the next thing I'm going to do is I am going to actually download this data. If I click this link, let me minimize this. I've actually already clicked it, so let me just pop this over here. This is the website for the Oregon Department of Education. I'm going to scroll down here to math, and you can see here's the 2018-2019 data. I'm going to be working with the data on economically disadvantaged, homeless, etc. folks. It's school level data for grades 3 through 8 in high school. Now the way I would do this, you can see I've actually already done it here. I can close that just to pretend like I'm starting from scratch. But the way I would do this with a different tool is I would actually just download this. So I would click it and then download it, and then I would copy it to whatever location I wanted it to be in, and then work with it from there. In R, because we can use that download.file function, we don't have to even go through that intermediate step. And that's helpful because it makes our work reproducible. Because then if we go back to it, say, next month or next year, we can see exactly where we downloaded that file from and even download it again, assuming the location of the file has not changed. So to do that, what I'm going to do is I'm going to right-click here and I'm going to get the address of that file. So I'm going to copy that address here. And now I'm going to switch back to R. And I'm going to use the download file function. That's actually from base R. We don't need actually any packages to use it. So URL equals, and I'm going to put this in quotes. And I copy that in. And then I'll do dest file equals. And I'm going to call this I should just call it that. That's fine. Actually, that'll be helpful because then I'll know yeah. So I'm just going to call it the same thing as it was originally. That'll actually help me to know in the future, which file it was. So I'm going to call the file the same thing. I'm just going to give it the same name as it has originally, which will help me to know in the future exactly what it is. Now you can see I ran this and it downloaded it, but it didn't put it in the data raw folder. So let me actually just delete that and run this again. Oops, that's not what I want. Data raw slash, let me delete that. There we go. Okay. Let me flip back here. And I'm going to do the same thing for the 2017-2018 data. So I'll actually just copy that, put it here. I'm going to change the URL that I'm using. And then same thing. Let me go ahead and run that. All right, as that is downloading, one thing that I like to do after I've downloaded files is I usually comment those lines out because I don't want to have to run them again. I don't need to download the file multiple times. And as you can see, it takes just a little bit to do it. All right, let me flip back here. Now I want to import these data into two separate data frames. I'm going to do math scores 17-18 and math scores 18-19. So let me actually make a new section, import data. Math scores 17-18 and math scores 18-19. And I'm going to assign that the results of ReadExcel, which I have access to because I've loaded the ReadExcel package. So I'm going to do path equals, and I want this here. Go ahead and run that and see what happens. So I've loaded that. Cool, it looks like I have what I need. Awesome. Wait, I'm just thinking about something. Actually, I need to look back because I think I made a sort of simplified version of this, and I'm trying to remember. What I did. Oh, that's right, that's right. So I think I actually just messed up the last little bit because I'm going to have folks download a file, and I'm going to demonstrate actually a file that I have worked with. So let me go back a couple lessons. The reason I did this, I struggled. I really wanted folks to just work with the raw data itself. Actually, let me just restart my session. But it ended up being just a little bit too complicated to do that. So there were some things that I wanted people to do with the data that basically weren't possible with the way the data was structured. So yeah, I made a few changes. So I just need to find I'm actually thinking maybe I'll show students the way you would do it for real data, and then because I'm also going to have them just download data from a GitHub repo, the kind of simplified version. So just kind of thinking through that. Delete this. Yeah, I think I am going to keep that, and then I'll kind of add on to that. Okay, let me close this. Just going to actually copy the addresses in here. All right. Now, for a number of complicated reasons, I'm actually not going to have you work just with this raw data. You can take a look at it if you want to, but I'm going to actually have you work with a slightly simplified version of this data that I've created. And I'm also going to work with a slightly simplified version. So I'm pasting the URLs here of the files that I'm going to have you use. So I would just do the same thing, download file, URL equals, put this here, and then dest file equals data raw, and I'll call this math scores 1819.slxs, XLSX, kind of a tongue twister. I'll do the same thing here, except for the 1718 data. All right, and then I'm just going to comment that out. And so you can see now I have math scores 1819 and math scores 1718. All right, let me make a new section now where I'm importing my data. And I am going to create a new object called math scores 1819. I use underscores in my object names. Hold on one second. Let me now make a new section for importing my data. So I'm going to do import data. I'm going to call this math scores 1819. I like to make all of my object names use snake case, which is the underscores. I make all my file names with dashes. I don't actually know what the name of that case is, but just kind of a convention that I use, worked for me. Do whatever you want in terms of your own work. So I'm going to now import this, and I'm going to run the ReadExcel function. Path equals, whoops, got an extra set of quotes there. That. Oh, okay, sorry. I got to load my packages again. Let me run that. And now I run that, and I have math scores 18, 19. Let me just open this up. Whoops. Let me close that. Let me go ahead and open up the Excel file and take a look at it. You can see it only has one sheet. I didn't actually put the sheet argument here, but I could. I could put sheet, in this case, equals sheet 1. That would give me the same thing. You can also do the number of the sheet. So I could do sheet equals 1, which will import the first sheet. I don't actually recommend that because someone could change the order of your sheets later on, and that could mess things up. So I'll just keep it as sheet 1 for now. So now I have my math scores here, and I'll take a look at this data in just a second, but let me go ahead and import the 17, 18 data as well. 17, 18, awesome. Great. So now I've imported my 2 Excel spreadsheets. I've downloaded them and I've imported them into R. And I have the code now that makes this entirely reproducible. So if I uncommented these lines, for example, I could run this and that would download the files. If I shared this with somebody else, for example, they could run this and it would work just the same for them. All right. Okay. All right, so let me do the your turn section. You'll be working with data on Oregon school enrollment by race ethnicity, and I'll show you this in just a second, but let me kind of lay out what I'm going to have you do. You're going to create a new project. Make sure you put it somewhere where you'll be able to find it again later, or not even later, like right now. You're going to download the 2 files, and I'm going to put the links down below in the Your Turn section on the website. You're going to use the download file function into a data raw folder, and you'll need to create that. Create a new R script file where you'll do all of your data cleaning work. And then I want you to import the 2 spreadsheets into 2 data frames, enrollment 17, 18 and enrollment 18, 19. And just FYI for folks watching live, these videos live on a website. So when I said, for example, the links are below, that's because when students are actually doing this course, there are links that live down below. All right. The other thing, just for folks watching, in addition to actually doing this and giving folks a Your Turn section, I then record videos that are the solutions for folks because I don't want folks to get stuck. So I'm going to go ahead and record that now. Let me just get the addresses. Hopeful that future lessons will not take as long. I'm sure they won't. I haven't recorded lessons for a course for a long time, so a little bit out of practice. I'll close this. All right, so let's look at the solution for this section. First thing I'm going to do, just create a new R script file. And I'm going to call this, that's not what I wanted to do. Let me save this. I'm going to call this data cleaning solutions. I am going to load my packages. So I'll do library tidyverse, library ReadExcel, and then library janitor. Okay, let me run that. Download files. So the first file that we're going to download, that's the location of it. So you do download file, URL equals, put that here. And then dest file equals, and I'll call this, I want to put it in the data raw folder, enrollment 1819.xlsx. Let me just copy this because I know it's 1718. All right, let me just run that whole thing. Great, I have enrollment there. You can see I have the files that I'm using for the My Turn section as well as the Your Turn section. Let me import my data now. So I'm going to create an object called enrollment 1819, which will be done using ReadExcel. So the path equals, and I can even just copy it from up here because that's where I put it. Oh, and actually, let me just comment these lines out so I don't run that again. And I'll do sheet equals, I'm pretty sure it's sheet 1. Yeah. All right, cool. And then I can just copy this for enrollment 17, 18. Awesome. Great, so now I have enrollment 1718, enrollment 1819. You can just ignore the math scores ones that I have for the My Turn section. All right. All right, for folks watching live, I'm just going to stop the recording since I'm done with that lesson. Let me just make sure. Oh boy, I hope that worked because otherwise that would be not great. Yep, looks like it worked. Awesome. Actually, I just want to try one thing really quick just to make sure. I will jump back on, or I'm not going to leave the stream, but I'm just going to kind of pause for a second. I just need to pull it up in iMovie and make sure I can do one thing with the recording that I made. And that's helpful. All right, cool. You may have just heard me replaying the video in iMovie just to make sure that I could work with it. And yep, I can. Awesome. All right, just check something. Okay. Just gonna kind of look through my next section, remind myself, oh, tidy data. Oh, you know what I'm thinking? I really like, let me see, oh, I can never find it. There is a nice, I'll just pop this screen over here so you can see me struggle to find what I'm looking for. A nice kind of flow chart, what am I trying to say? That shows kind of the process for working with data. Yeah, that's what I want actually. Actually make a new, I'm going to edit my slides. I've made all my slides in R Markdown using the Sharingan package. So I'm just going to add a slide here. All right, I'm going to reknit this. I am curious who's watching. If you're watching and want to share, I'd love to know who you are and where you are. Feel free to put that in the chat, whatever platform you're watching on. Okay, cool. Let me close this. Let me refresh this. Let me just make sure. Yeah, I got that. I don't actually need that title. Let me center this to center. Whoops. Middle. Hi, Laura. Thanks for joining. Let me make sure. Got this working. Cool. All right. Oh, hey, Francis. Yeah, thanks for following. You should definitely feel free to work in another window. I know this is a lot of me kind of stopping and starting, kind of the nature of it. So thanks for joining, and yeah, hope you're getting some good work done at the same time. just thinking through talking about tidy data. I've actually posted on Twitter before that. Hold on, I'm just thinking through this. Yeah, in terms of these 3 rules of tidy data, I basically always just see the first one. Each variable forms a column. So that's the example that I'm giving in this. I know there are all sorts of other ways that data can be untidy. Yeah, basically that's the one that I'm going to work through. Awesome. Tyler from New Jersey, hello. Thanks for watching. Oh, hey, Patrick. Patrick, I owe you an email. I will get back to you later today. Thanks for watching from Nairobi. All right. All right, cool. I hope you enjoy the pictures that I chose for the backgrounds. There's no good picture for tidy data, so I just tried to come up with something that was tidy. All right, let me go ahead and get started on this section. Oh, I need to record. Actually, sorry, I'm just gonna record, rename the last file, and I'm going to hit record. All right, awesome. All right, so let's get started. So the next thing we're going to talk about is tidy data. The tidy there is the same thing that gives the tidyverse its name. In the book R for Data Science, which if you haven't read is fantastic, I'll link to it in the Learn More section. It's free, it's available online, it's by Hadley Wickham. I refer to it only half jokingly as the Tidyverse Bible. This is in one of the earliest chapters. It's kind of a workflow that Hadley and Garrett Grolman, the other authors, suggest using when working with data. You import your data, and then before you do anything else, you tidy it. Now, they have kind of a number of things here in terms of transforming data, visualizing, modeling. I don't do any kind of modeling. I've written about that in the past. I use R purely for descriptive statistics, data visualization, etc. I would say even if this middle section doesn't represent exactly what you do, and again, it does not for me, whatever kind of work you're doing to understand your data in the middle here before you communicate results, your work is going to be improved if you tidy it early on. Yeah, just thinking. And I'll talk shortly about what exactly tidy data means. There's a whole philosophy of it. It doesn't just mean clean data, because when people say their data is clean, that can mean a wide range of things. There's a specific set of criteria for determining whether data is tidy. We'll get to that in a second. Before we do that, I actually want to talk about untidy data and kind of like what the problem is, why you'd want to actually tidy your data in the first place, because I don't think people are going to be interested in thinking about tidying data unless you actually encounter some problem. So let me give an example. If you recall that German speakers data that I imported before, we had state, and it's showing up kind of weird, but if you remember, this was German speakers 2017, 2018, and 2019. Now, let's say I wanted to do something, and I've actually just behind the scenes imported this to a data frame called German speakers numeric. There was some other stuff with the data that was not numeric that I needed to just get rid of in order to work with it. So what if whoops, I think I went to that too fast. Let's say that I want to get a total number of German speakers across these 3 years. One way you could do this is by, oh wait, I don't think I even, why do I have group by there? I don't need that group by, hold on. Let me reknit this. Okay, cool. Let me make sure that worked. Yep. Refresh this. Yeah, okay, perfect. Now it actually showed up better. Did I show that full screen? I'm not sure if I even showed that full screen. I'm gonna just start from the beginning. Okay, let's talk about tidy data. The tidy that we're talking about here is what gives the tidyverse its name. It's a whole philosophy of how to work with data, how to structure data. And it's what's going to enable us to get our data into a format that's going to work really well with the tidyverse set of packages. This visualization, this workflow is taken from our For Data Science freely available book by Hadley Wickham and Garrett Grollman. I'll put the link in the Learn More section. And they suggest that after importing your data, the very first thing that you should consider doing is tidying it. Before you get to any kind of transformation, visualization, modeling, etc., put your data into a tidy format. Now, just as an aside, I don't do any modeling, but I think no matter what you're doing in this middle section to understand your data, you're going to be well served by starting out by tidying your data and getting it into an easy to work with format. To talk about tidy data, I usually like to present an example of untidy data because I think that's really the best way to understand what the problem is that we're dealing with, because I think without a problem, you're not going to be invested in thinking about why you would want to tidy your data. So let me actually refresh this to see if I can have it show the why is it not doing that? Okay. So let me look at the data that I imported before. This is actually called, you know what, I don't even need to, hold on, let me just do one last thing because I'm just going to have it not echo. So in other words, not show this German speakers numeric because I don't, basically I have some character data in the German speakers data frame, just German speakers, not German speakers numeric, that I'm going to use as examples later on, but I don't want to use that now, so I made a separate one called German speakers numeric. But as you can see, I guess I talked through it, it's really unnecessary to talk through the details. So I'm just going to pretend like it's the same data frame. I'm not even going to actually, I don't want to show that German speakers numeric thing. Okay, perfect. Okay. Let's take a look at the German speakers data that we had from before. Just as a reminder, we had states, and then we had 3 years of data, number of German speakers in 2017, 2018, and 2019. Let's say that we want to get a total number of German speakers. The way I would probably think to do that with the data structured in the way it is I would do German speakers. Now I called this German speakers numeric for a number of reasons that don't really matter, but just so that it would be easier to work with right now. Say it's the same thing as our German speakers data frame from before. So I would say mutate total equals, and I'm just adding number of German speakers 2017 plus number of German speakers 2018 plus 2019, and then I'm just selecting state and total just so we can see that. So you can see I've got each state and the total. Now you might be thinking, that worked fine, what's the problem? Well, wait, so I thought I had another slide where I was going to talk through the problem, but I think I was just intending actually to talk through it. Well, the problem is this. In our data set here, we only had 3 years of data. What if we have 10 years of data? What if we have 25 years of data, 100 years of data, and it's super wide? Are we really going to type out every single variable? The best way instead to deal with this is by tidying our data. Initially, for most folks, what they think of that as doing, a really common scenario is taking super wide data and pivoting it, which I'll show you in a second, to long data. So what I want to end up with is something like this. You can see now I've transformed my data, and I'll show you how to do this shortly, so that I have a state variable, but now I also have a year variable, and then I have a number variable. So now instead of having a number of German speakers 2017 variable, a 2018, and a 2019 variable, I've actually converted that into a single variable, which is year, and then I have another variable that's just number. So you can see this is the same exact data, just represented in a different way, and this is actually tidy data. Now, working with this data, I could really easily summarize it. I could just do a simple group by, so group by state, and then summarize so that total equals sum of the numbers. So just to flip back to the previous, flip back to the previous slide. If I group by state, so for example, I'm grouping Alabama together, and then I'm doing sum of the number, so it's just doing the sum of these first 3 numbers, so the 426 plus 395 plus 711, and that gives me 1532. And it's done the same thing, of course, for all of the states. Oh, you know what I'm realizing? It's pretty minor, but Arkansas has NA, and I'm guessing there was a missing value in the Arkansas. Yeah. Let me go back. Oh, shoot. How do I... let me go back here and just change this. All right, so I'm just adding na.rm equals true. Let me make sure. Let me refresh this to make sure I've got the most recent version. Okay, cool. Now Arkansas. Okay, I'm just thinking about where to start. All right, so here you can see I have done what's called tidying my data. And I'll show you how this works. But for right now, just take a look at the structure of my data. Whereas before we had state and then 2017 number of German speakers, 2018, 2019, and 3 separate variables. Now we have a single state variable, but we also now have a year variable. So whereas it was spread wide across 3 variables before, that's now a single variable. So we have number of German speakers 2017. So you can see the variable name from before is now actually an observation in the year variable. And then number is the number of German speakers in that particular year. Often when you're tidying data, you will go from wide data to long data. And you can see we've done that here. Now, if I want to tidy my data, or if I want to summarize it, why does it have the row numbers? That is weird. It doesn't have row numbers anywhere else. Anyone know? If you do, please let me know. If I ungroup it, does that? No. I was just wondering, Francis, you asked what the question was. You can see it's got row numbers on this slide, whereas it doesn't have them on any other slide. I'm trying to figure out why. No, ungrouping doesn't do anything. I mean, it's not the biggest deal, but as you may be picking up, I'm a little bit persnickety when it comes to formatting stuff. At like further down. Yeah, that's what I'm thinking. It must be something to do with the summarize, but I really don't know. Let's see something. The tibble. Same structure. Okay, I probably won't worry about it. It's not the biggest deal, but I'm just not quite sure. All right. All right, you can see now, after I've put my data into this tidy format, I actually created behind the scenes a new data frame called German Speakers Tidy. Now I can group by state, and then I can summarize so that total equals the sum of the number variable, and I'm removing any NAs. Just as a reminder, whoops. So for example, for Alabama, it's getting the sum of 426 plus 395 plus 711. And that's 1532. And it's done the same thing for all of the other states. Now, the advantage of this is that, before when I showed you the untidy data, the wide data, and I put in the names of the 3 variables, the 2017, 2018, 2019, I said, if you had 25 variables, you'd have to put in all 25. Because we have put our data into this tidy format, now I can just do this group by state and then summarize total equals sum of number. And if we had, for example, 10 years of data or 100 years of data, this same code would give us a summary for Alabama for every single state. So it enables us to be much more efficient in terms of how we write our code. There are 3 rules of tidy data. Each variable must form a column. Each observation forms a row. Each type of observational unit forms a table. We're going to talk primarily about number 1 and number 3. I recommend checking out the tidy data vignette, which has really nice examples of other types of untidy data. Yeah, so definitely check that out. For number 3, the main thing to think about, and I'll show this in a second, is oftentimes when you get data, when you import data in a spreadsheet, for example, it'll actually have multiple types of observational units. So for example, you might have some student data that is looking at enrollment by race and math scores or something like that. And you would be better suited to actually separate those out in the beginning before tidying your data. It'll make your life a lot simpler. Number 1, each variable forms a column. Oh, sorry, Francis, I just saw your comment. Yeah, it's weird. I don't know what's going on, but I'm just going to leave it. Let me go back. So there are three rules of tidy data. Each variable forms a column, each observation forms a row, and each type of observational unit forms a table. We're going to focus primarily on number 1 and number 3, but if you want to read examples of other types of untidy data, definitely check out the tidy data vignette, and I'll link to that in the Learn More section as well. So for number 3, the main, actually, let me see. Yeah, I want to actually talk through the issues on the German speakers data before I look at the math proficiency scores data. Actually, maybe not, because I think it'll be better exemplified with my math proficiency scores. Yeah, let me do that. So let me go ahead and open up my data, and let me take a look at which principles of tidy data are being violated. Minimize the Going Deeper course, and let me open the Going Deeper DK. All right. So going back to my data cleaning R script file, let me take a look at the math scores 1819. One cool trick I actually learned recently is if you command click or control click and on the name of an object, it'll actually open it up in the viewer for you, which is really cool. So looking at my data, I have a school ID, student group, grade level, and then this is looking at the number and percentage of students who are proficient in math. So you can see number of students proficient at level 4, percent proficient at level 4, etc. So thinking back, let me actually flip back here. So my 3 rules of tidy data. Each variable forms a column, each observation forms a row, and each type of observational unit forms a table. So first thing, just looking at the data, in terms of each observational unit forming a table, we could work with our number and percent together. But it's actually going to be simpler for us just to separate those out. And I'm just going to work with the number to make that simpler. So let me do this. Actually, wait, no, sorry, because this example is not to actually do anything. It's just to look at it. Let me start this over. let me take a look at my data and see which principles of tidy data it violates. All right, I have opened up my data cleaning file, and you can see I have my math scores 18, 19. One cool trick I learned recently is if you either control click on Windows or command click on a Mac, it'll actually open it up for you. You do that on any object that you've created. You can see I have school ID, student group, grade level, and then number of students proficient at level 4, as well as percent of students proficient at level 4. There are kind of 4 levels of proficiency for math standardized assessments. Same thing for levels 3, 2, and 1. So thinking back to the rules of tidy data, each type of observational unit forms a table. If I had some other type of data in here, say I had, for example, reading scores, I would want to strip that out. And I would want to create an object just for math scores as well as one just for reading scores. I don't have that. I do have number and percent. So for simplicity, I'll probably end up just working with numbers separately from percent. The other thing that I'm noticing, looking at it and flipping back here, I want each variable to form a column. Now, I have number of students at level 4. Similarly to, let me start that over. When I was working with my German speakers data, you remember I had year as well as the number of German speakers in a single variable. So for example, I had number of German speakers 2017, number of German speakers 2018, number of German speakers 2019. Here, I actually have the number and level in a single variable. So for example, well, these are all, there we go, there's not missing variables. So number level 4 is actually showing 2 things. We're seeing the number of students and we're seeing the level of proficiency. So we're going to need to actually tidy this to make it so that the number and level are in 2 separate variables, because as you can see, they're kind of scrunched into a single variable. Okay, let me do the yours turn. All right, for your turn, first thing I want you to do is read the tidy data vignette. It is super helpful. I know not everything is going to make complete sense right now, but it'll really kind of give you a sense of what tidy data is and how you can begin to start dealing with it. Then I want you to take a look at your data and see which principles of tidy data it violates. And this is the enrollment by race ethnicity data. All right, let me do the solutions for this one. Okay. All right. After you have read the tidy data vignette, if you take a look at your data, and let me open this using command click, I can see with the enrollment data, and I'm just going to look at 1 year's data. You'll actually see if you open them both up, they're basically this. They are the same, just for different years. You can see I have the district ID. This is district level data. This shows, for example, the number of American Indian / Alaska Native students for 2018-2019, percent. And then it's the same thing for various groups here, as well as then it has grade level data. So already I'm seeing, let me actually flip back here. Whoops. In terms of our 3 rules of tidy data, each type of observational unit forms a table. This is a great example because we have grade data and we have race data. We don't need those to be, they start out in a single data frame, but we don't need that grade level data to be in there. So in a minute, we'll actually get rid of that. The other thing I'm looking at, because we're just going to look at race ethnicity data, is that it is wide, which is usually a pretty good hint that it's not tidy. And so, for example, 2018-2019, American Indian, Alaska Native, and then the number. So I'm actually seeing almost 3 things there, right? In this single variable, it tells us what year it is. It tells us the race / ethnicity group. And then we also have the number of students who are in that group. So we're definitely going to have to do some serious work to tidy this data in order to work with it efficiently from here on out. All right, I'm just looking at the time because I gotta not go too long because I've got some other things I'm gonna need to work on today. I think I'll probably go for like 10 or 15 more minutes. And thanks to all of you who are watching along. It's really actually good accountability for me to have know that folks are watching, because otherwise I just kind of, you know, start looking at stuff on Twitter or whatever, that kind of thing. So let me actually stop recording, rename that to tidy data, and then I'm going to record again. This will probably be the last lesson I'll do, actually. Now that you hopefully are beginning to understand the principles of tidy data, let's talk about how you actually reshape your data in order to tidy it. The first function that we are going to talk about is pivot longer. It helps us in situations where column headers are actually values, not variable names. Just to flip back here really quick, remember with our enrollment data that you're working with, for example, the American Indian Alaska Native is a column name, it's a variable name right now, but it should actually be a value. In other words, we want there should be a variable for race ethnicity. It should not be the name of a header, because the variable here is actually the number of students. All right. The way it's going to work is this. This is just kind of like a generic example. So you start with your data frame, and then we're going to use pivot longer. The first argument we have to look at is what columns we're going to use. So calls equals, and you list whatever columns you're going to use. And I'll give you an example of this in just a second. Then there is a names to argument. So for example, well, actually, again, let me show you the example shortly. Whatever the identifier variable is, that's the name you're going to put right there in the names to argument. And then finally, the values to, so the name of the value variable. Okay, let me give you an example here. Let me refresh this. For some reason, it keeps messing with my variable names. There we go. It's like if I don't refresh it when I get to it, it doesn't like it. Okay, let me give you an example using our German speakers data. So if you remember, I showed you how I tidied it. I showed you the result of it, but I didn't show you how I actually did that. So let's go behind the scenes so you can actually see how that works. This is our original data frame where we had state and then, number of German speakers, etc. You hopefully remember this. You've seen it a number of times now. So we are going to do German speakers and then pivot longer, and I've done calls equals minus state. What that means is I'm saying I want to pivot all the columns. So in other words, take all the columns except for the state variable. Don't change that, right? So you can see now when I do that, the state variable remains, but now I have a new variable here, which has the year, and then I have a new variable here, which is value. You can see by default, if we don't list the names to, if we don't give the names to argument and the values to argument, it'll automatically just give this column, this variable, just the name, and this one will be called value. Okay, so to change that, we can just add names to equals year, because this we can see is basically showing the year with some extra stuff, which we'll get rid of shortly. And then this column is showing the number. Okay. Now, this isn't, I think I need a intermediate slide or something here. Actually, no, I can just do it by talking. Okay. Now, you may be wondering, this pivoting longer has made our data tidy, which is great in terms of analysis, but oftentimes you actually want to display it for people. And for a lot of people, having it in this long, tidy format is not actually a great way to look at it. There is a function called conveniently pivot wider, which does the opposite. So for example, if I add this on, and I wanted to have each state be a variable, I would just say pivot wider. Wait, I don't have an ID call there. Why do I not have that? Come on. Uh-oh, did I freeze this? No. Whoa. Come on. I think I forgot a column or something, maybe. I was just trying to indent. Okay. Just make sure that works. Yeah. So I don't think I have to list ID calls there because there's only I think it just chooses everything that's not selected, but it's just going to be better if just talking to myself now. All right, let me let this knit and then I'll do that again. right, perfect. It's often helpful. We use the pivot longer function to help us tidy our data. Oftentimes, though, you actually want to go the opposite direction in order to display your data. For example, to put it in a table, something like that, to enable people to easily consume your data. Not analysts, that is, kind of more layperson. So the way we do that is with pivot wider. It's going to have a similar format. We're just going to identify what's the ID column. And then instead of names to, names from, what variable do we want to do to have the names of our, oh boy, that's looking funky. There we go. The pivot longer function is the pivot longer function enables us to tidy our data, to take it from wide data to long data. Oftentimes, though, we actually want to go the opposite direction. We want to make our data show up nicely in a table, for example. And for that, we can use pivot wider. Oh, why does it keep doing that? So for example, if I want to show, no, actually, let me keep it on this side. Let's say, for example, I want to have a table that shows each state as its own column. Right now I have it in long format, but I want to make it wide. I could use that pivot wider function. I can say, what do I want to keep as my ID call? So that's the first argument here. Let's keep year, the year variable. So just, whoops, a reminder, this variable as the ID calls. And then I want to say, which variable am I choosing the names from? So if I go back here, I'm saying use the state variable to make names, one for each distinct observation of state. And then the values from the number variable. So that's this variable over here. So in other words, the value here, Alabama 2017 426, comes from right here. Okay, so that's pivot wider. All right, so for my turn, I'm going to create a new data frame called Third Grade Math Proficiency 1819. And I'm going to do this. I'm going to use filter to only keep rows where the student group variable is total population, all students. I'm also going to use filter to only keep third grade students. I know this isn't actually about tidying yet, but I want you to kind of practice some of the skills that you would have learned in the fundamentals of our course. I want you to then use select to only keep variables related to the number, or sorry, let me redo that because it's not you doing it, it's me doing it. I'll then use select to only keep variables related to the number, not percentage of students who are proficient in math at various levels. And then I'm going to use pivot longer to make my data frame tidy. Okay, let me go ahead and do this with the 1819 data. So I'm just going to actually add onto this right after I import it. And let me take a look at it again. I'm going to do, I want student group to be equal to total population. So student group equals total population, all students. And then I want to do filter. I only want to keep third grade students. So I'm going to do grade level equals grade 3. Oops, I did not close that. So you can see it's actually paused right there. It's like stuck. Just hit escape a couple times. Run that again. So you can see now I just have total population grade 3, which is what I want. Next thing was to only include variables that are about number, not about percents. So there are a few different ways you could do this. So I'm going to do select for variables. First thing I want to do is I want to keep school ID to grade level. Although actually, to be honest, I don't even need those. I can actually just keep school ID because obviously student group and grade level are all the same now. I know what they are. Oh wait, sorry. I should actually, let me flip back real quick. Sorry. I asked you to make a new data frame called third grade math proficiency. So let me, I'm going to make a new section called clean data. I'm going to copy this down here. So I'm going to run that again. So now I have math scores 18, 19. Let me actually start this over again. Okay, let me make a new section, and I'm going to call this clean data. So I'll be working on cleaning my data. And the first thing I asked you to do was create a new data frame called third grade math proficiency 18-19. And I'm going to make this. So I'm going to start with the math scores 18-19. Then I'm going to filter so that student population equals, and I just want to do total population, all students. And then I only want to keep third grade students. So grade level equals grade 3. What did I do wrong? Oh, student group. All right, let me start that over again. Okay. Let me start out by making a new section called clean data. First thing I'm going to do is I'm going to make a new data frame called third grade math proficiency. And to create that, I'll start with the math scores 18-19. Now I'm going to filter so that student group equals total population, all students. Whoops, I got a space there. Let me go ahead and run that and just make sure I'm getting what I want. Yeah, excellent. Now I need to filter so that grade is only grade 3. What was it? Grade level. Cool. Now I have all students grade 3, which is what I want. Next thing I asked you to do was to keep only variables related to the number, not percentage of students who are proficient in math. Okay, let me use select for this. And I didn't put this in the instructions, but I'm going to keep the school ID, of course, because I need something to have as a school ID. In addition to the school ID, I want to keep just the variables that have number. So the way I'm going to do that is I'm going to use the contains helper function, and I'm going to put in quotes number. What that will do, and this is covered in the fundamentals course, is that will keep the school ID variable as well as any variable that contains the text number. So if I go over here, you can see now I have school ID, number level 4, number level 3, number level 2, number level 1. Awesome. Now I need to tidy this. Okay. So I have number level 4, and what's going on here is that the number of students as well as their level is wrapped into a single variable. So let me tidy this, and to do that I'm going to use pivot longer, calls equals, and there are a couple ways I could do this. The simplest way, at least to my mind, is just to do minus school ID. And let me go ahead and run that. And you can see when I run that now I have school ID, then name, and value. The other way I could do it here is I could, instead of saying using the minus syntax, I could, let me actually rerun it so it's back like it was. I could select these variables. So I could do, for example, number level 4 to number level 1. See if I do that, it gives me the exact same thing. Either way works. I'll put it back with the minus school ID just because, I don't know, I find that more intuitive. Now looking at this though, we didn't name this variable and we didn't name this one either, so let's use the names too, and I'll call that, or sorry, no, that should be, I want to keep it proficiency level. I want to make it easy to work with. And then, whoops, values2 equals number. So now you can see I have school ID, proficiency level, and number. And now my data is tidy insofar as it's only covering one topic. And the proficiency level here is separate. In other words, it's not hooked together with the number and their proficiency level. It's in a separate variable. For your turn, I'm going to have you do something very similar. I want you to create a new data frame called Enrollment by Race Ethnicity 1819. Start with the Enrollment 1819 data frame. Then I want you to select the district ID variable as well as those about race ethnicity and get rid of all others. And I've given you a hint here to use the contains helper function within select, similar to how I did. Then I want you to use the pivot longer function to convert all of the grade variables into one single variable. And additionally, I want you to use the names2 argument to call that variable race ethnicity. And then I want you to use the values2 argument to call the values that are left number of students. Okay, let me flip over here. Okay, let's work through this. So I'll make a new section, clean data. And I'm going to make a new data frame called Enrollment by Race Ethnicity 1819. I'm going to start with the Enrollment 1819. Then I asked you to select the variables. So just if I pop this open here, I see we're going to select district ID. And I don't want any of those grade variables. So let me do this. Select district ID. And I'm actually going to do minus contains grade. So you can see when I do that, now if I pop this up, whoop, that did not work. What did I do wrong? Why did that not work? Okay, weird, that worked. Didn't work if I had district ID. No. Okay, that's super weird. I don't quite get that. Well, I'm going to actually just do it a slightly different way. Then I'm going to use select to select the variables I need. And what I'm going to actually do is I'm going to do minus contains and in quotes grade. So what that will do is it will select anything that does not contain the text grade. So it'll select district ID all the way over here. You can see I don't have, for example, grade 1, grade 2, etc. It does have kindergarten because kindergarten does not have the text grade in it. So let me go ahead and just add another line. I'll just do the same thing. Whoops. And I'm just going to add kindergarten here. All right. Yeah, so now I just have the race ethnicity data that I want. But let me actually, so I asked you, did I say this? Oh, I'm going to need to change these instructions. Okay, let me go back into my project. Going to let this knit. Okay, I got to wrap up shortly, so hopefully this will work soon. I got a typo. Okay. Whoops. Delete this. Actually just restart my session, run that again so it looks like I'm back where I was. Yes, of course, there's no package called tidyverse. Tidyverse. Okay. So for your turn, I want you to do the following to create a new data frame called enrollment by race ethnicity 1819. You're going to start with the enrollment 1819 data frame. I want you to select the district ID variable as well as those about number of students by race ethnicity and get rid of everything else. I've given you a little hint there to use the contains helper function. Once you've done that, then we're going to use pivot longer to convert all of the grade variables, which right now are spread across. Wait, did I say? That's totally a typo as well. Okay, this is a good sign that I should probably wrap up soon for the day. Okay. Okay, for your turn, you are going to create a new data frame called enrollment by race ethnicity 1819. I want you to start with the enrollment 1819 data frame, and from there, select the district ID variable using the select function, as well as those that are about number of students by race ethnicity, not percentage, just number. Get rid of everything else. Remember, there's going to be some data about grades in there as well, so you're going to want to get rid of that. And I've given you a little hint for how you might do that. Oh, no, not grade variables. Next, you're going to use pivot longer to convert all of the race ethnicity variables into a single variable. Remember, they're wide right now. There's one column for each race ethnicity group. We want those to be long. We also then want you, we being I, want you to use the names2 argument to call that new variable race ethnicity. And then additionally, use the values2 argument to call the new value variable that's created number of students. All right, let me do the solution, and then hopefully this will be it. Okay, so in doing this, you may have created a new section for clean data. Let me go ahead and make a new data frame, which enrollment 1819. So I asked you to select just the district ID variable as well as those about number of students by race ethnicity. There are a number of different ways you could do this. So I'm going to start out by doing minus contain. So actually, let me just open this up. first thing I want to do is get rid of all of these columns that are about grade. So I'm going to do minus contains grade. Now, when I look at it, oops, I don't want to look at the 1819 one. I want to look at the new one, enrollment by race ethnicity 1819. Now what I can see is I've gotten rid of all the grade data except for kindergarten because that does not have the text grade in it. So let me go ahead and do the same thing, except I'll put the text kindergarten in there. So you can see now if I scroll all the way over to the right, I don't have that anymore. So now I just have the race ethnicity data. Now, I asked you to get rid of anything that's about that's percentages. So the one bit of text that I see that's across all of those columns is the word percent. So let me do this. Same thing, except I'm just going to change minus contains percent. Now I have district ID, and then I think, let me see, yep, now I just have one column for each group, and then just shows the number of students in each group. Flipping back to my instructions, I now need to pivot longer because this is not tidy, and so I am going to use the pivot longer function. So just looking at this, starting out, you might just do like calls ID minus, or calls equals minus district ID. And if I do that, now you can see I have district ID and then name and value. Now I want to make my variable names more descriptive. So I don't want it to be called name. I want it to be called something else. So I asked you to have it be called race ethnicity. So I'll do names2 equals race ethnicity and values2. So the column that now has our values here, I said make that be called number of students. And you can see now I've begun to tidy my data. Okay, I am going to stop the recording. And I am actually going to end the stream now. So thank you all for watching. I will be back tomorrow, same time, if you want a little preview. Next, we're talking about dealing with missing data. You may have noticed, for example, there are a bunch of like dashes here. So talk about how to get rid of some of those. And yeah, thank you again for tuning in, for providing accountability for me. If you're interested in the course, it's on the R for the Rest of Us website. It's pre-sale right now at a lower price. And yeah, I will look forward to hopefully seeing some of you tomorrow.